tutorial and here's technical video. Wondering about Ethernet IP, CIP, how to capture and do analysis about this protocol? This video will show you how. We're going to be using Wireshark and the next Rockwell tools. The Integrated Architecture Builder software, Studio 5000 ControlLogix PLCs, and Stratix 5700 Managed Industrial Ethernet Switch. The Integrated Architecture Builder is a free software. You can use this software to design different types of networks. For this lab, I'm using it to show you my network topology. I'm going to be using two ControlLogix PLCs, one Stratix switch, two laptops. One of the PLC will be sending a double integer value to the second PLC. The configuration of the switch is very straightforward. Both PLCs are going to be connected over the same VLAN. PLC 1, PLC 2 will be in port 2 and port 4. Studio 5000 is going to be running in my laptop connected to port 1. And the most important for us today will be port 8. Port 8 is going to be working as a power mirror. Let's see the configuration one more time. Now that it's clear what we're going to be doing, let's see how we set up the Stratix 5700. Traditionally, you have to run the express setup. It's done already in my case. Next, I'm going to configure the smart ports. Remember, both PLCs, the laptops, they will need a special configuration. If you see next, I'm connecting so far port 1, 2, and 4. Let's see the configuration of these ports. Port 1 is going to be set up as a desktop for automation. Port 2 and port 4 will be automation device. The configuration of the role in a smart port is simple, as you can see right now. Remember that we're using VLAN 1. Port 8, it would be set up as a power mirror. How it's done? Basically, you choose the role, port mirroring. Remember, the source interface is one of the PLCs. In this case, the PLC connected in port 4. The Stratix switch that I'm using has full firmware, so has routing features. I'm using VLAN 1 for this lab. Remember, don't use VLAN in your OT networks. As you can see here, port 2 and 4 are in VLAN 1. Port 1 is in VLAN 1. Wondering what is supposed to be port 8? Think about it. Let's go back to the dashboard. You can see here that I'm using port 1, 2, and 4. Port 8 is going to be used for the second laptop running Wireshark. Once I connect that laptop, the status of this port will change. You can see that next. This port is following one of the PLCs, specifically the PLC that is connected in port 4. The configuration of the Stratix 57 is complete. We have two PLCs, one in port 2 sending information to the PLC in port 4, and we are listening to port 4 using port 8. Let's see in RS links if these two PLCs has a healthy link. Both PLCs communicating properly, as we can see here. Let's play with the Studio 5000 next. Studio 5000. In my PLC connected in port 2, I'm running a script. Structured text, very simple. This PLC is the L36ERM. In port 4, I have the L33ERM. The script basically follows a simple condition. If it's true or false, I will be changing a number. If it's true, it's going to be a large number. If it's false, it's going to be a very short number. The tag in L36 is set up as a producer. The connection settings basically shows that it's going to allow 2 consumers, and the data type is a double integer. Let's see the tag in the L33. I'm using here what is called a consumer. Let's see the settings. The connection is linked to the producer that I have in my second PLC, and the RPI is 20 milliseconds. If we have a producer and consumer configuration, we know that this is an implicit message. It's a real-time message, and there are specific rules about this type of messaging. We're going to have the PLCs going back online, and we're going to start showing how the script that I'm running in PLC in port 2, the L36, will affect the PLC that is connected in port 4, the L33. And the goal is that while we're doing this change, we're going to capture the package that I reached in PLC in port 4. And this is done because the laptop that we are connected in port 8. So let's see here how this script affects PLC 2. Every time that the condition is true or false, a number would change. And we can see on the screen how this is updated. So one more time, we can see here how PLC 2, the L33, is being updated. Now it's time to use Wireshark and follow up these registers across the network. Setting up Wireshark is simple for what we're going to do. Here, I'm showing you that I have only one interface in my laptop that is enabled. It's set in promiscuous mode. As an output, I'm going to set up a file, PCAP type, and the rest are pretty much the default settings that you can find. We're not going to take any special consideration about them now. I start capturing packages, and we see that there is no specific values that we're going to be seeing right now, unless we filter the capture, and then we can identify source and destination. Remember, I'm running this while I'm using a script in PLC connected in port 2 that is updating a register in PLC connected in port 4. We're going to capture for a few minutes package, and then we're going to do an offline analysis of the capture. Once we have our PCAP file, then we can work offline with Wireshark. In order to be effective, we're going to be using some filtering options. We're going to identify the PLC source and the PLC destination. And remember that this is a UDP connection, so we're going to identify the port used in UDP, specifically the port used for Ethernet IP. You can see on the screen the filter. And now it's very straightforward for us to work analyzing the packet that we capture. What we have here, let's see. We have a frame. We have a series of bytes that represent something. So let's try to see what is that. First, we see the destination and the source MAC addresses. We can see the source address and the destination address, IP addresses. We see here the port used by the source and the destination, UDP 2222. Under Ethernet IP, we see the sequence address item and the connected data item. Finally, we have the CIP I, the data. This is what we want to read. And this is what we're going to analyze in detail. The configuration of this package follows specific rules. I'm showing you here the structure of that package. Again, we're going to focus on a very specific part of this package. CIP I basic analysis. Remember, we're analyzing an implicit message. UDP, real time. The structure is very specific, and there are a specific type of values that we're going to be looking into. Once we have an idea about how is the structure of this package, we can take one of them and dissect it. First, we identify the connected transport packet and the sequence address item. Then, we can identify the implicit messages itself and the RPI. In this case, remember, we use 20 milliseconds, so we can see how often one of these PLCs is pulling information from the other one. And right at the bottom, we have the data, one of the small numbers. Remember, we are using decimal. We have to make a conversion to hexadecimal, and then we have to take care of the endianness. Here you can see the big number, the same concept, the same length, and the same structure that we've been following for CIP connections. ControlLogix has more videos where you can find the express setup of the Stratix switch, how to use the integrated architecture builder, many more things about PLCs, motion, HMIs, virtualization. If you have any question about any section in this video, please send us your questions and we're going to get back to you. Also, don't forget to follow us in social media. My name is William Nieves. Thank you very much for your time and attention today.